In this lesson, we'll talk about logical operators, relational operators, and we're going to start talking about conditional operators. Now, you already know about relational operators. You can compare if two numbers are equal. You can compare if two numbers are not equal. You can compare if one number is less than the other. A lot of these you know already. The way they're written, the way those operators are written in Java is a little different. When you're comparing if two numbers are equal, you have to use two equal sign. Remember, one equal sign is an assignment statement, but two equal sign is when you're comparing. And when I want to do greater than, I'd use the greater than sign just like normal, but if I want to do greater than or equal to, there's no such thing on the keyboard, so I have to use greater than and then an equal sign. So that's really one thing there. That's one relational operator. So these things, I guess, kind of make sense. The not equal, just put the exclamation before the equal. The only really important thing is when you're doing, or the important thing to remember is when you're doing comparison of equals, you have to use two equal sign. If you use one, it's going to assign the value and it will never check the condition. Now, when you're checking a condition with a relational operator, you're going to get a value true or false. That's why this is called type Boolean. It has two values. Remember, Booleans are usually zeros or ones, true or false. It has two possible values. By the way, when you're using comparing string values, there are other ways to compare them, but the easiest way to compare two strings right now, if you're checking if two strings are equal, for example, if fruit 1 is apple, fruit 2 is orange, you want to see if they're equal, do fruit 1 dot equals and give fruit 2 as the argument, and it'll give you true if they're equal, false if they're not. So in this case, it would print out a Boolean. It would print out the word false because it's false. Okay, so keep these in mind. We're going to show how we use them in a little bit. Logical operators, ands, ors, and nots, that's what they are. And is written with two ampersands, or is written with one ampersand. If you do one ampersand instead of two, it actually ands them together. It would actually and the two things together, the two arguments together. So if you had a whole bunch of bits, and would take, anytime there's two ones in the same slot, it would take them as one, otherwise it'd take it with zero. But anyway, don't worry about that right now. Just know that you have to use two ampersands if you're comparing two conditions, two vertical bars, or ors, two ors if you're comparing an or for two conditions, and one exclamation if you're comparing a not. So what this says, I guess these are the basic rules of logic. I don't know if you've seen these before, but if you have two things that you're comparing, and the first one is true and the second one is true, that's required. That's the only way that an and operation is considered true, if the first one and the second one is true. Look, if I say, if you are in 10th grade and you're a boy, the only way that's true is if both of those things are true. If you're in 10th grade but you're not a boy, not true. The whole thing is false. So what this does is when it's evaluating the truth value of an and expression, and also true for an or expression, it does something called short circuit evaluation. So it knows that as soon as it hits a false, when it's doing an and operation, as soon as it hits a false, the whole thing is false. So it evaluates it left to right. So in this case, it would evaluate the first one. If you're in 10th grade, yeah, you're in 10th grade, so keep going. And you're a boy, true, yes, so it evaluates it true. If I get to this one, are you in 10th grade, true, and are you a boy? No, but what if you're a girl? That's a false. So that whole thing is false. This one, if you're in 10th grade, but what if you're a 9th grader? Well, don't even bother doing the second part of the and. That's called short circuit evaluation. It will keep evaluating until it finds that the whole statement is false, and it'll stop. And again, in this case, if you're in 10th grade and you're a boy, well, what if you're a 9th grade girl? Well, this one already is false, so I don't even care whether you're a boy or a girl. I already know you're not the condition I'm looking for. And or is a little different. Or if both of them are true, if you're in 10th grade or you're a boy, that would be true. If you're in 10th grade, what if you're a girl? It's okay because it's an or. You're in 10th grade or you're a boy. Well, it doesn't matter if you're a girl, you're still in 10th grade, or would evaluate to true. The same here. What if you're a 9th grade boy? That works because maybe you're not in 10th grade, but you're still a boy. So that's true. Well, if the statement is if you're in 10th grade or you're a boy, well, what if you're neither of those? Well, then it's definitely false. The not sign, the exclamation, if you're doing a not on a true statement, it evaluates to false. If you're doing not on a false statement, it flips it, basically, again, turns it into a true. And just so you know, if you don't have parentheses, the not takes precedence over the and and the or. So the not is evaluated first. There's something called De Morgan's law. If you take logic in college, or just basically these De Morgan laws show you how to switch from ands with nots into ors and the reverse. So if I have, let's see, if it's not the case that you're in 10th grade and you're a boy, that's like saying either you're not in 10th grade or you're not a boy. Okay, so either one of those would have the same value. So you can just kind of look at these and see. It makes more sense maybe when we look at numbers. I want something that's not the case, that x is less than 5 and y is equal to 0. Looks like there's an extra underscore in there. Just ignore that. So I want a number where it's not the case that x is less than 5 and y is equal to 3. That's the same as saying x must be greater than or equal to 5 and y is not equal to 3. So that's kind of what De Morgan's does. Conditional statements are very important. They allow you to change the flow of execution in a program very easily by testing certain conditions. You can do an if statement, and if you test a certain condition, it will only execute the body of that if statement if the condition is true. If the condition is false, it'll skip right over it. You can do an if else, where you test the condition of the statement. If it's true, it does the first part of the conditional statement. If it's false, it will do the else part of the statement. So in this case, I'm checking if x is positive. Well, that's basically checking if x is greater than 0. So if x is greater than 0, it will execute x is positive. If x is not greater than 0, it will just skip that part. It'll skip this part between here and continue. Suppose I want to check if x is even. This says determine if x is positive or negative. That comment should say even or odd. Okay, so I'm checking if it is even. That's basically, remember the modulus operator. If I divide x by 2 and I get no remainder, if I get a remainder of 0, so if x divided by 2 has remainder equal to 0, the equal is checking if the remainder is equal to 0, then x must be even. So if that's true, if that condition is true, it's even, I print out it's even. If it's false, if I get some kind of remainder, that means it wasn't even, so I would execute the else condition. So if this is true, I execute here. If it's false, I do not execute this first part, I just execute the second part. So true, only I execute this. False, I execute this. I'm going to hold off on a code sample until I get to nested conditional statements in the next lecture that I come up with, because that shows something that's a little bit more interesting. It also shows some of the more uses of the logical operators.